Welcome students, we are back with another lesson. In this lesson we'll discuss energy. So up till now we have discussed work done. When a work is said to be done, the work is said to be done whenever a force acts on a body which causes the body to move in a particular direction. Now in today's class we'll discuss energy. So what is the energy? The energy of the body is defined as the amount of the work it can do. Let us suppose consider this boy. This boy is throwing a stone towards this window. So he is doing a work to throw this stone in a particular direction. So in order to do this work, he has to supply some energy. So what is the energy? The amount of the energy required for the work to be done. Similarly, in this case, suppose if you have a revolver, the amount of the energy required to shoot this electron from this pistol is known as your energy. Similarly, in this case, the amount of the work done in moving the stone. Can you see the stones? They are moving in the downwards direction due to the gravity. That means a force is pulling them downwards, which is gravity. Fine. So some amount of the work has been done earlier. They were at the top. Now they are falling downwards. That means some work is being done. So what is your energy? The energy, it tells us about the capacity, how much a work can be done. If this boy has less energy, that means he cannot throw the stone. So the lesser the energy, the lesser amount of work done. So energy gives us the idea about the work done. So to summarize, the energy of the body is the capacity to do work, or I can also say anything which is able to do work possesses some energy. Fine. Now energy can be further classified into kinetic energy and potential energy, which we will discuss later. For now, let's just stick to the important points. Now energy is measured in the same unit as your work done. So in last lecture we saw that work is measured in joules. So energy will also be measured in joules. Now if work is also measured in joules, then energy is also measured in joules. Therefore, the energy will also have the same dimensional formula as your work done, which is mL square T to the power minus 2. This is the dimensional formula for your energy. Fine. So now let's discuss the first type of your energy. The first type of your energy is known as your kinetic energy. Kinetic energy is the energy which the body acquires due to the motion. Fine. Let us consider in this case. This kid is throwing the stone. Now because the stone is moving, therefore it acquires this energy, and this energy will be known as your kinetic energy. Similarly, let us consider this example. Suppose you have a revolver and you shoot the bullet. Now the bullet will be moving in the forward direction. Now since it is moving in the forward direction, therefore it will acquire some energy, and this energy is known as your kinetic energy. Similarly, let us consider in this case a stone. Earlier the stone was at the top. Fine. After some time, what happens? Due to some rumble or due to some disturbance, the stone started to move downwards. Now because of its downward motion, it acquires that energy, and the energy acquired due to the downward motion is known as your kinetic energy. Right? So the kinetic energy is the energy possessed by a body by virtue of its motion. Now if I want to write an expression for the kinetic energy, so we will consider an object which has a mass m moving with a velocity v. Now in that case, the kinetic energy of the body can be measured as half mv square, where m is the mass of the body, v is the velocity. Fine. So if a heavy object is moving, that means greater mass. greater the mass, greater the kinetic energy. Fine. Similarly, if a body is moving very fast, that means the body moving very fast also has a high kinetic energy, because higher velocity means higher kinetic energy. So the expression for the kinetic energy is half mv square. Fine. Based on the kinetic energy, next we'll discuss a very important theorem, which is known as your work energy theorem. This work energy theorem has been asked in the year 2020 for 2 marks in your boards. Okay. So the question states, as the question goes, state the work energy theorem and prove it for a constant force. So what does the work energy theorem states? It states that the work done by the net force acting on a body is equal to the change produced in the kinetic energy of the body. To understand this work energy theorem, let us consider an example. Suppose you have a disk. Okay, this disk is rolling in this direction. Fine. That means it will be moving in the forward direction with the velocity v1. Fine. So if I want to find out the kinetic energy of this disk, how will I write? The kinetic energy of this disk will be half of mv1 square, where m is the mass of this disk and v1 is the velocity with which it is moving in the forward direction. Now what you will notice as the disk rolls up till this slope. Fine. Now as soon as it crosses this slope, what will happen? Will it move with the same velocity v1? No, the velocity will increase because it is moving in the downward direction. So in this case, when the body is rolling down along the slope, let us say it is moving with a velocity v2, and this velocity v2 is greater than your velocity v1. Fine. So there are two cases. One, when the body is rolling along this first slope. The second case, when the body is rolling along this downward slope. Fine. This is your case 1. This is your case 2. In case 2, what will be the kinetic energy of the body? If the body is moving with velocity v2, then the mass of the disk, okay, it will remain same throughout whichever situation, because the mass does not changes. Fine. So in that case, I can write half m. Fine. But this time it is moving with a velocity v2. Therefore, the kinetic energy of the velocity will be half mv2 square. So earlier it was having a kinetic energy half mv1 square. Later it is having the kinetic energy half mv2 square. So according to the work energy theorem, if I want to calculate the work done by the disk in rolling along these two slopes, fine, this slope and this slope. So to find out the work done, what I can do is I can use the work energy theorem. This work energy theorem says that the difference in the kinetic energy between the two cases, that is kinetic energy in this case minus the kinetic energy in this case, will give us the amount of the work done by this rolling disk. Fine. So this is your work done. Next, let's prove the work energy theorem for a constant force. To prove it for a constant force, consider a body of mass m. Fine. Now suppose you are applying a constant force on this body. The constant force F is acting along the body. Because of this constant force, what will happen? This body will start to move in the forward direction. The body starts to move in the forward direction with some acceleration A. Fine. So this is the direction of the force, and because of this force, a acceleration comes into a picture. This is your acceleration. Fine. Okay, so what it means is that if the body is in motion, let us say the body is moving with a velocity u, right? Because of this force, a acceleration comes into a picture. This acceleration, what it does, it increases the velocity. It increases the velocity with which the body was moving in the forward direction from u to, let us say, it increases the velocity to v. So what it means, earlier, consider a body which was moving with the velocity u. You applied some force. Because of this force, acceleration came into picture. This acceleration, what it does, it increased the velocity from u to v because of this force in this direction, which causes a acceleration on this body of mass m. So let us consider that this body acquired the new velocity after covering some distance s. Fine. So in that case, we can apply our equation of motion. So the third equation of motion, what it says, the v square minus u square equals to twice of as, where v is the final velocity, u is the initial velocity, a is the acceleration with which the body is moving, and s is the distance covered by the body when the velocity changes from u to v. So this is your equation of motion. Now on this equation of motion, let us multiply half m on both sides of the equation, on the left hand side of the equation and on the right hand side of the equation. So after multiplying half m on both sides, we will get half mv square, half mu square, and here half m into multiplied with 2as. This 2 and this 2 get cancelled, so I will get mas. And we know from Newton's second law, the force, applied force, can be written as the product of mass times acceleration. So here you have mass times acceleration. So instead of ma, I can write f dot s. And what is f dot s? The applied force multiplied with your displacement. This is known as your work done. Fine. So f dot s is known as your work done, w, and half mv square is your final kinetic energy. Suppose this is the final state and this is your initial state. So at this state, the final kinetic energy is half mv square. And if this is your initial state, that is your starting state, then I can write half mu square as the initial kinetic energy, ki. Fine. Therefore, I can express my work done as the difference between the final kinetic energy minus your initial kinetic energy, which is known as your work energy theorem. The work energy theorem by the net force is equal to the change produced in the kinetic energy. So there is a change produced in the kinetic energy which causes a work done. Fine. So this is your work done theorem. Fine. So that's it for today's class. Thank you. And if you have any confusion, please feel free to ask. I will re-explain it to you again. And in our next class, we will solve a numerical based on the work energy theorem, which has been asked in the year 2018. Fine. So that's it for today's class. And again, thank you.